Hello, everyone. Today we're going to discuss a text about honeybees, social distance to prevent disease too. I will read the text and paraphrase it line by line, then we will do the activities and I will play the listening recording for you, but I do not share the answer key with you. So let's begin. The first part says humans are not the only animals that practice social distancing to deal with a deadly pathogen. So it means humans are not the only ones who stay apart to avoid disease. A new study shows honeybees change their behavior and use of space to avoid spreading Varroa destructor mites, which feed on bees' organs and can harbor nasty viruses. Here we have the information about a new study, and this new study shows that honeybees also change their behavior. And they do this to stop tiny bugs called Varroa mites from spreading. Researchers observed these changes in wild and caged bees infected with the mites, which are one of the biggest global threats to honeybees. And these mites live on bees and can carry harmful viruses, and scientists saw that bees changed their actions in the wild and in cages, and varroa mites are one of the biggest dangers to honeybees. The team found that in the infected wild populations, older forager bees would perform foraging dances, which they used to show other bees where to find food near the periphery of the hive. Here, we see that researchers found that sick bees stayed on the edges of the hive, and these bees danced more to show others where to find food. They did not stay in the center of the hive. These actions seemed intended to avoid sickening the young nurse bees and larvae in the hive center. This helped protect young bees in the middle from getting sick. The infected wild bees also groomed one another for parasites more intensely in the center of the hive among the more valuable young bees, and the findings were reported in Science Advances. Sick bees also cleaned each other, so groomed one another means they cleaned each other more, especially in the center. And this cleaning happened near the most important young bees. So these young bees are very important. They are valuable, so they are important. The study was published in Science Advances. So the findings here refers to the study, the research. We interpreted this change in the social organization as a possible strategy to limit the spread of the parasite within the hive, says lead study author Michelina Buscedo, an agricultural scientist at the University of Sassari in Italy. This person, Michelina Buscedo, is a lead scientist, and she's Italian. So she explained that the bees' actions may be because they do this to stop disease from spreading. And look at the sentence. She said that the bees may do this to stop disease from spreading, and Puscedo works at the University of Sassari in Italy. As predicted, the infected bees in cages received more grooming than uninfected bees. So infected bees in cages were cleaned more than healthy bees. But contrary to expectations, the infected bees engaged in more socializing as well, such as touching antennae and sharing regurgitated food. But these sick bees also spend more time being social, and they touched each other's antennae and shared food. Regurgitated means they ate food and they brought the food that they ate back to their mouth. So it's like vomiting, but they shared that kind of food that they ate. This may reflect a trade-off between limiting disease spread and maintaining communication, the authors say. And scientists think this shows a balance between stopping disease and staying connected. Let me see, where was I? Here. Probably social distancing is too costly at a small scale or within the same cohort, notes senior study author Alberto Sata, also at the University of Sassari. And this person, Alberto Sata, is a senior scientist, and he said keeping distance may be hard in small groups, and he also works at the University of Sassari. Black garden ants, lobsters, birds, and non-human primates also show social distancing behavior. So other animals like birds and lobsters also keep their distance to stay healthy. But for any social animal, keeping one's distance comes with a cost. But for social animals, staying apart can be difficult. So comes with a cost means it can be difficult. So this was the text. Now we have these exercises. I want you to read the questions and decide whether the sentences and decide whether they are true or false. You can pause the video and do the activities. Later we can check this exercise together in class. And here we have 2 discussion questions. Again, pause the video, answer the questions. Now, in this part, we have a listening activity. I will share the audio. Please listen and let me see. It says, in what order does the speaker discuss the following? So you should write A, B, C, D, E here. You have it. You should order them. Which one is number 1? Which one is number 2? Okay, you should order them. Write numbers.
This is Scientific American's 60-Second Science. I'm Jason Goldman. Epidemiologists have long known that socially connected individuals, like friends, family, and coworkers, are more likely to transmit pathogens to each other. But when an individual becomes obviously ill, their social connections become temporarily reduced. When we feel sick, we tend to stay away from others. And when we appear sick, others tend to stay away from us. That distancing usually helps to slow down the spread of a pathogen. But not all social relationships work the same way. Parents of sick children will continue to care for those children at the risk of their own health. And that devotion is true beyond humans. Consider vampire bats. They usually groom their own offspring as well as other bats, and they share food. But illness changes some of those activities. To track illness and behavior in a vampire bat community, researchers injected some bats with a substance that triggered their immune systems. The bats felt less well than usual without actually suffering from a disease. In this situation, unrelated bats stopped grooming each other. But mothers continued to care for their offspring, even if one of them seemed to be infected.
In these changes in grooming, there was a difference between unrelated bats and maternal relationships. So what it looked like was that sick moms kept grooming their offspring, and healthy moms maintained grooming their sick offspring, whereas we saw like reduction between unrelated bats.
Sebastian Stockmeyer, a graduate student in integrative biology at the University of Texas at Austin, who led the study. But food sharing was different.
So it looked like that sick bats still received food from others, but they were groomed less by others. And so there are these infection-induced changes to social behaviors caused by these like sickness behaviors, but that they might vary depending on what behavior you actually observe.
So not only does the type of relationship matter, the type of behavior does as well. It's as if the bats set up this sick time rule. I'll feed you by regurgitating a blood meal into your mouth, but that's it. The study was in the Journal of Animal Ecology. The social relationships among vampire bats work a lot like human friendships. And when trying to understand the spread of infectious diseases through social networks, says Stockmeyer, vampire bats teach us that the type of relationship and the type of interaction are important variables to consider. Thanks for listening. For Scientific American's 60-Second Science, I'm Jason Goldman.
Okay, so you listen to the audio, to the podcast. Now order these sentences, and in class we will check them together. And about the discussion questions, you should read these questions based on the listening and answer them. And here you're going to summarize the points in the podcast and just compare vampire bats and bees, and also you can compare them to human beings. Don't forget to mention these points. Points about grooming, feeding each other, socializing, and communicating. Thank you so much, and see you next time. Bye-bye.